All right, so we've already kind of looked at this map thing before, but that'll be where we start off, just so you know that you can refer to it during our calculations and stuff in this chapter. I did want to point out that I did give you all the conversions in case you need help. So this was everything that was covered on this last chapter. So if you need that, you can always refer to that. If you don't need that, it's cool, whatever you need. The periodic table number in grams, that just means your molar mass. Okay. All right. So looking at our map, just a reminder, our big focus is that mole town is in the middle. So the unit of the mole is our main conversion point. So we always have to go there, right? So we always have to convert to moles in order to go across an equation, a balanced equation. So in mole town, if you remember, we talked about this right here, right? And we said that every time you hit mole town, you're going to have to cross the bridge. So in stoichiometry, when you are talking about two different things on a balanced equation, you're going to have to go into the mole in order to talk about the other one, basically, okay? And that is made up of your coefficients, okay? And that's what's written on, it should be on your paper, okay? So I will be, when we start doing our calculations today, I will represent it with a little bracket like that, okay? And so that you know that whenever you see that, that's where you put coefficients, okay? All right. We've kind of spent a lot of time with grams, all right? So in Gramland, we've done a lot of conversions between the grams to moles. And so now what we're going to be looking at is going from grams to moles, across the mole bridge, coming back to Gramland. And your big conversion there is using your molar mass, okay, whether you're going to multiply it or you're going to divide it. And you'll know that because you're going to bring words down to the right. So then it's less trying to memorize stuff, okay? Particle city is the one with Avogadro's number. So you can kind of see that. Sorry, I know this is in the way. I'm just going to push them up there. Okay. So Avogadro's number is our conversion to any of their chemistry words. So atoms, molecules, formula units, particles. And so you guys have gotten a little experience with that one. And then over here, you've had like one homework problem about this, but this is Volumeville. Volumeville we use when we're talking about gases at standard temperature pressure. STP means nothing to you right now. It will when we get into the actual gas law chapter. But we are going to start practicing a couple stoichiometry questions with it. So just know that your conversion is the 22.4 liters for every 1 mole. Okay? So you kind of have this to refer to when you come across those problems. But the big idea is that you can't go from any of those cities to the other cities without going through mole town. Okay, so you do need to convert to moles. That's your big rule, I guess you could say, in this chapter. Okay? All right. Any questions on the map? We're all good? Sweet. Okay. All right, let's look. If you flip the page over, you have this on the back. So this is for my people who are not really all about the map, and that's okay. So if you need a little more structure, I gave you this little diagram that has arrows, and it tells you what to do. So you're more than welcome to refer to this. You can replace any of the outside boxes, or you can add the outside boxes, like out to the right and left, for the gases, for liters. So you can add that in there too if you wanted to. But this is just here for you guys. And then if you look on across, it kind of shows you that actual path of what you're doing when you're converting. So I'm going to show you with railroad tracks because it's just the way that I always do it. But this might help some of you guys who need like a diagram of what exactly you're doing. Okay? So you have that whole resource to you. Okay? So, all right. So we're going to look at the next page. There's no questions. We're good? So now we're just going to take really brief notes. It's not going to take us too long. I really wanted to get us right into some practice. But stoichiometry, we're now there officially. So we've done a lot of practice with units, a lot of practice with conversions, a lot of practice with all of that good stuff. Now we're just going to mush it all together and actually do some chemistry kind of math, okay? So stoichiometry is a Greek word that just means to measure, if you wanted to know. okay? And it involves the mole relationships between reactants and products in a chemical equation. Okay? It's based on the law of conservation of, what do you think? Mass, yeah. And so, since we're going to be involving the moles and relating them that way, what do you have to start with? What kind of equation? A balance, yeah. So you need to make sure you have coefficients or everything is balanced on both sides to respect your law of conservation of mass. All right. Mole ratio. Okay, so a mole ratio, you'll hear Miss Fogel call this a mole bridge, just out of habit. So just know that the proper word is a mole ratio, okay? And the mole ratio is just a conversion factor that relates the amount the amount in moles of any two substances in a reaction or equation. Okay? Put off to the side, this involves coefficients. So when you are writing your mole ratio, you got to pay attention to those coefficients. So for example, we have this little reaction going on here. What kind of reaction is it, by the way? Synthesis. Good. So we're creating some, what is this guy? Who's he? Calcium oxide. Good. Awesome. All right, cool. So if I wanted to know what is the mole ratio of calcium to oxygen, what would you guys tell me? Two to one. 2 to 1. Okay, so you're literally just looking at your coefficients. Okay? If I wanted to know what is the mole ratio of calcium to calcium oxide, you guys would tell me 2 to what? 2 to 2. Okay, do we know where these numbers are coming from? Seeing a couple blank stares. So, okay, just know they're coming from these coefficients. Nothing in front of something means a 1. If you need to put a 1 there to remind yourself of that, you can. Okay. All right. So we got mole ratio, and in most of our problems, we're dealing with stuff that we're getting from the lab. And the useful tool in the lab is the balance. So we're going to do a lot of things in grams. So you're going to be using your molar mass conversion a lot. Okay. And so the molar mass is just the mass in... what's the unit that we use for mass? Grams of 1 mole of a substance. It's a conversion factor that relates the mass of a substance to the amount in moles. All right, cool. So those are just basic ideas that we're going to be doing all of our 4 problems around. So before we draw out the 4 different types of problems, okay, just recall back when we first did these notes, I told you they're all based around the same skeleton, the big gram to gram one where as long as you're bringing their words down to the right, you're just following your map, okay? And so I want to have you guys look at the bottom of your page. You guys have this little recipe here, and this is another way to think of it, okay? When you go to solve any kind of stoichiometry problem, the first thing you got to do is make sure it's balanced, right? So if they give it to you in words and say that you are synthesizing calcium oxide, you have to make an entire balanced equation, okay? Then you need to identify the chemical and measure. What do I mean by measure, by the way? What do you guys think? I mean, like units. I couldn't find my electronic version of this, so I couldn't change it. Sorry, guys. All right, so I'm just talking about units, okay? But it says identify your given and your unknown. So what I like to do is I like to underline the given, and I like to circle my unknown. Okay, I like to underline my given, circle my unknown, so that I know where I'm starting, where I'm finishing, and then it'll be easier for you to use your notes to figure out what type of layout it is. But honestly, if you have a starting point and you just continually bring words down to the right, you're gonna do just fine. You don't even have to look at your notes. Okay? All right. Then it says to change the measure, the units of the given, into moles. So you go to mole town. Whether you use Avogadro's number, you use molar mass, you use 22.4. You got to go to the mole town, right? Once you're there, and now you're going to form a ratio. You're going to cross your mole bridge. Okay? And then finally, change your unknown number of moles back to what was requested. Okay? So it's really just that simple. I think the part where I see people struggle the most is that they aren't bringing the words down to the right. You just get so excited to just like try to put a bunch of numbers into all these squares, and you put them all in the wrong spot because you're not paying attention to your units. It's really based around dimensional analysis here. Okay. All right, so your 4 types of problems. Keep this short, sweet, and simple. We're gonna write out the long one with all the details in it, and then the other ones we won't put as many details in it. We'll just write the little skeleton of it. Okay, so the longest one is the gram of A, 2 grams of B. A and B just represent 2 different compounds in a chemical equation. Okay, they're usually across the arrow, but you can relate 2 reactants or 2 products together too. All right, so I would start with my grams of A. And the first thing I would do is bring those words down to the right. Grams of A. Bless you. Bless you. And then I would convert to moles of A. Yep, so I'm traveling to Mole Town. So I started in Gramland, now I'm traveling to Mole Town. So what is this relationship? How many moles am I always talking about? 1. And then what number am I going to put down here? The atomic mass, the molar mass, yep. Good. And put MM, all right? So this is where, it's helpful to chunk it together. Anytime you see moles and grams together, so on top of each other like that, whether one is on top or the other, it's always going to be a 1 mole to molar mass, okay? All right, so our next step, because we're not where we want to be, we want to get to grams of B. We're going to bring our words down to the right. So I have moles of A. I'm in Mole Town, so what do I need to cross? Yep, cross the mole bridge to moles of B. Okay, remember kind of the story. It's a magical mole bridge. You can change it into whatever you want. All right, so here, this is my mole ratio, or my mole bridge. Okay, so what numbers do I need to put into this area? Coefficients, good. So I'm just going to write coefficients underneath it. And just know whenever you see this bracket, that's what we're talking about. Okay? That's your mole ratio. All right, cool. So we're on our next step because we still aren't in grams yet. We're going to bring moles of B down to the right. And we're going to end with grams of B. So here's that mole to gram thing again. So how many moles are we talking about? 1, and how many, what do we put for grams? The molar mass. Good. Okay? So all of them are going to be kind of based around this layout. You're just going to shorten it either from the right, from the left, or just go right in the middle. Okay? So supposedly this is the most difficult one, but I think since you guys made it through yesterday, I'm hoping it looks a little bit easier. So, all right. The next type would be a mole to gram one. So if I gave you information in moles, mole to grams. All right, so moles of A, grams of B. Okay, so if I had that, I would just start with my moles of A. Words come down to the right. I'm in Mole Town. What do I have to do? Cross the bridge. So we got moles of B. Okay, this is Mole Bridge. I'm not going to write details on this one, okay? And then you're going to bring your words down to the right. You're going to convert into grams. And this right here is your 1 in molar mass. Okay? So you see it just kind of shortened it, but it's still based around the same idea here. Okay? Then you have a gram to mole. So you'll have grams of A. Words come down to the right. We're going to convert into moles of A. So we know that this is a mole gram thing. So once again, 1 in molar mass. Words come down to the right. And we are going to cross the bridge and stop there. And that's the mole bridge, because we're ending with moles of what we want. Okay, and finally, your last one, okay, even easier, is a mole to mole. So, you literally are already starting in Mole Town. You cross the bridge, and you are done. Okay? But if you notice, if you take a look at the big picture here, no matter what, you cross that bridge. There is a mole bridge in every single one of those calculations. Okay? That's what I mean by you always will cross it. For your first one, it's such a difficult one. No, I'm just kidding. This one, it's saying how many moles of HF, so I'm going to circle moles of HF, are needed to react with 3 moles of this. So I know that the underlining is my starting point. The circled stuff is what I need to find, where I need to end. Okay, so as soon as I see this in my calculation, that's where I stop. So if you notice, I've already put this here for you. Oh, sorry, I skipped step 1. What should I have checked for? What do I need to check up here for? Coefficients. Make sure it's balanced. So if I ever give you coefficients, it's probably balanced. All right, unless I am giving you a question and saying, is it balanced? And then, yeah, you know what I mean. So, so if there's coefficients, you can go ahead and assume that I balanced it already for you. So this one's balanced. We're good to go. Cool. So let's bring those words down to the right. I'm going to bring moles of Na2SiO3. And what do I put on top of that? Well, those will be the numbers, but for my units, I would say moles of, bless you, HF, exactly. And then, yes, what she just said, it's the bridge. That's your mole bridge. That's your coefficients, okay? So, like I said, a lot of people like to put the little bracket there, or they, like, label it, or they, like, highlight it because they know, oh, I crossed the mole bridge. Cool. It's coefficients. Easy, okay? So if it helps to make sure you always have one, do it. All right, so here we get our coefficient. So what is in front of this guy right here? A 1. Good. So is that going top or bottom? Bottom. What goes on top? 8. Good. So we have 3 times 8 divided by 1. Yeah. Good. Okay. Somebody asked me earlier about sig figs. I will give you the sig figs for the rest of them. When you are dealing with moles, unless I'm giving you a very specific amount, like 3.2, you really, like for this one, don't do 20, basically. Moles is sometimes a counting number, and so just don't worry about sig figs as much if it's like one of these where it's a mole to mole, okay? Otherwise, all the rest of them, if you kind of look down the page, these all have different things. I'm going to fix letter D, number 1D. and we're going to put a little decimal after the 100 so that it has 3 sig figs. Otherwise, that would be a very ugly answer. Okay. All right, I will do, let's see here. Do you want me to do letter D with you guys? So you can see one worked out, the long, okay, and then the other 2 are the short kinds. All right, so we'll do letter D together. So we're going to bring grams of HF down to the right. Okay, so I'm in Gramland. Where do I need to go? Moles. So I'm going to go moles of HF. Okay, what do I put in this kind of thing where I have moles and grams together? 1 mole and molar mass. So molar mass is, let's see, 1.008 plus, I got 20.006. Okay, cool. Now I'm going to bring my words down to the right. Okay, I'm in Mold Town. What do I have to do? Good. So across the mole bridge. So we've got moles of NaF. I am so sorry that I did not do this to start with. I'm blinking out now. All right, there we go. Okay, so here we're going to look at coefficients, right? This is our mole bridge. So what goes on the bottom? 8 goes on the bottom. What goes on the top? Good. Okay, cool. Now I'm going to bring my words down to the right. And I need to go back to Gramland. So this is just a molar mass again. So 1 mole, and then yep, 41.988. Good. Okay, cool. So from here, remember when you go to type this in, what I've recommended in the past is take the whole top. So multiply 100 times 1 times 2 times 41.988. Get an answer. Leave it on the calculator, though. Don't write it down or anything. You get an answer, and then automatically push divide. You can't see that. I'm sorry. Get an answer, push divide, and then you're going to say this 20, push divide again, push the 8, push divide again, and then the 1. So if you just keep pushing the divide sign over and over and over for everybody on the bottom, you won't mess up. Obviously, the other option is do parentheses, multiply the top, divided by parentheses around everybody, multiplied by the bottom. Okay? So you got 2 ways to do it.